Hello, this is Jaime and Jan. We are live from Munich. We have questions and answers. And what about Jaime?
Yeah. Scopes.
Scopes.
Yeah.
Hey, that's nice. Where should I click?
Yes. Now we
do the
can,
techniques.
We can use this one. So yeah. Okay. Yeah. Today we're gonna discuss about power supplies, oscilloscopes, your questions and your answers.
Yeah.
And a very special thing is we're gonna give a scope away.
This will be a very nice thing. We have from Harmac, we have some special guests, and we are giving away to our attendees on the internet. We're giving away one HM1002 oscilloscope.
Yeah. Perhaps can you make a sneak peek?
A sneak peek.
Sneak peek.
A sneak peek.
Could be great. Yeah. Just that's enough.
Just a sneak peek.
Enough sexiness for now. Yeah. Take it out.
For now it's me. Okay. Of course, people could register to our webinar at first, and well, we had some questions, and I just tried to give some answers. But we also have experts of Harmac here. We'll be inviting them soon, and well, let's see what we have on questions from our readers.
Yeah, go ahead.
Okay. At first, we want to talk about power supplies. Of course, in the lab we have different power supplies. We have single power supplies. We have dual power supplies, multiple power supplies. Sometimes with two regulated power supplies and one 5 volt or one 12 volt. Regulated only the voltage and regulated on the current. Yeah.
So linear.
You see here an example. You can get it pretty easy. If you start on with designing electronics, it's the first thing. It will be the first thing you need. If you don't have a power supply, you will not be able to power your.
Nothing's going to happen.
No, nothing's going to happen.
Yeah.
And every time with a battery, that's not the kind of thing you want. Of course, you need also a bit of power. A battery cannot handle, for instance, it can handle 9 volt, but it cannot handle 1 amp. It will diminish very soon. So, well, we got a question. If you start on it, take it one.
Yeah, we go ahead.
And I put a small issue on the power supply for starters.
Yeah.
For starters.
Well,
and for starters, you will need, if you start electronics, you will need a power supply, a single power supply. It needs to be regulated from 1.2 to 24 volts for starters.
Yeah, and not even necessary sometimes. I think for the hobbyist range.
Yeah, 18 volt or 12 is sometimes when you're working with operational amplifiers. It's a bit low. It's a bit low. But you can do that from 1.2 to 15 volts. It's perfectly. And then you have to have a voltage measurement on it, or at least an indicator on how many volts you're putting on it, or else you will burn your PCBs really easily. It's not that necessary if it's not current regulated, but it should definitely be voltage regulated, or otherwise it will not be useful. Up to 1 amp for starters, that's okay. You will get sometimes a burned PCB or a burned component, because if you put 24 volts on it at 1 amp, it's still 24 watts, and it has to go in somewhere.
And actually, the fuse will be, you know,
if you have a fuse, but usually it turns into heat, and heat is bad for components.
Then the magic smoke is released. And the components no longer work.
Magic smoke, and if the magic smoke is released, it will not work again. Okay, let's see what we do need for people who are more advanced in electronics and doing more PCBs and more circuits. They will need at least a dual power supply, and then regulate it from 0 volts to 30 volts.
So for our attendees, do you mean that it has to? It's 2 channels are required at least. So you can you can set 2 different voltages.
You don't have to throw away the first power supply for starters, because you will need it at some point. You will need it to just do a quick look on a PCB or this or whatever. But you just keep it in your shack, and you buy a new one that's more advanced and has a dual power supply.
At least 2 channels.
2 channels regulated from 0 to 30. In case you didn't notice, at this presentation here, I wrote 0 to 30 volts.
Yeah.
The previous was
24. So 1.2 to 24.
Yes,
right.
that's right. 1.2. 1.2 is a voltage that you will need, and most of the regulated power integrated circuits, they can be regulated from 1.2 or 1.25 at least down to 30 volts or 24 volts. So you can easily also make your own power supply and just start with it in your shack.
Yeah.
I apologize if we sometimes have some
we have feedback
surround. But this is live, people, so it's on the fair. There's a lot of people standing around. So this one has from 0 to 30 volts. That means that the better power supplies, you can regulate them from 0 volts up to 30 volts or 32 volts, and you will at least need 3 amps.
Wow, well that sounds massive for for a project you are building at home, so to say.
Yeah, but imagine you're just building a small amplifier. You will need maybe 30 volts or so, or 28 volts to get it really working, and you will need a negative and a positive power supply. So that's why you have to have a negative and a positive power supply, and then 3 amps. It's only 90 watts. So 90 watts on an amplifier.
It's not that much.
It's not that much.
Yeah.
So, but for you can always build the proper power supply just for your amplifier. But for testing, this is ideal, and it's ideal because you can.
Once you know your working range, so to say, then you can build a brand new power supply.
It's also nice if you would, if you have a regulated current supply, because then you can start at maybe half an amp, and then if nothing going up in magic smoke, then you can crank it up, just crank it up to maybe 3 amps, and then see how it's doing.
Yeah.
If the magic smoke's not coming out, it's good.
Not coming out, then we're on the bright side.
Yeah.
Okay.
Also, we have you have to have current indicators because you want to know how many current your circuit is drawing.
Consuming.
It's consuming. It's nice to know because then you will know. Do I have a short circuit? Do I have some integrated circuits or some components that's getting hot or so, and you can see that. Because you have an idea when you start, you have an idea how many current that your circuitry should draw. I mean, if you have, for instance, an LCD display, you know that it will take at least 70 milliamps if it's 2 times 16 with background, so you have an idea. So if that circuitry starts drawing 1 or 2 amps, you know.
Yeah, or if it goes up, it probably, the power supply probably automatically switch off.
Well, not all power supplies do that, but the better ones, they have this current cutoff, so you can adjust it. If you have the current cutoff set out at 500 milliamps, and you just plug your circuitry in.
If the current goes up that threshold,
501, it's switched off.
Yeah.
So that's nice to have.
Yeah.
I think we'll go on to the questions from our attendees. Yeah. Maybe we could look if there are any questions from our attendees now.
I'm sure we have. Okay. First question from Mr. Orbit. Mr. Orbit, I hope you're there.
Yeah.
It's actually a familiar name, so he's joining usually. So that's good. And he's asking, are there quick and simple solutions to convert a switching power supply to a PC to a lab power supply? So he's asking if you can turn your very simple ATX power supply from your old computer, if you can turn that into a lab power supply, because it has fixed outputs, as far as I know, like 5 volts.
It has 12 volt, it has 5 volt. Yeah. Sometimes it has 3.3 volt.
Yeah, right. Yeah. So
those are voltages you can use. You can use the 5 volt, you can use the 12 volt, you can use the 3.3
They're
volt.
Fixed.
It's fixed. It's fixed. You cannot regulate that. You cannot regulate it in current. You cannot regulate it in voltage. If I was Obama, I would answer to this question, yes, we can.
Yes, we can.
But since I'm not, I would say on the whole question, no, there's not. Why is that?
Why?
We just developed, it was in, I think it was in October.
Yeah.
We developed a little PCB, or it was not a little PCB, it was a PCB like this, and we took a PC power supply and we converted it into a lamp power supply. It wasn't easy. So if you're asking, is there a quick and easy and simple solution to do that? It's no. The answer should be no. And you do not always want that. It's better to have a power supply that you from a decent manufacturer.
Obviously,
use it. It's like an investment. If you if you need to use it once in a year, then you can do this.
Obviously, don't spend that much money. Or grab one from friend.
That much money, but it's like an investment. It's like a soldering iron. If you buy once a decent one, then it lasts. It lasts a lifetime. And that's the same with power supplies. If you buy a decent one, then I have an old one that I had it for 10 or 12 years, and it's still alive. It's still working perfectly. So that's a trick. That's not the answer is no. It can be done, but not quick and not easy.
So it's better for Mr. Orbit to know that it's better to build one from the scratch or just buy one commercially.
I hope he looks at the Elektor October or looks at the website and looks at how it's done, so he can have an idea and then decide for his own. Is it easy enough for me, or is it too difficult for me?
Right. Perhaps, he's experienced enough. Perhaps
I think we have more.
Go for it. Yeah, perhaps exactly. We would like to know the input of someone who is a real expert.
Well, we have here on the shack we have a nice power supplies. Maybe
perhaps we can show that. Let me just connect it because.
We are now inviting Shaban from Hame, and he's. Come in.
Come?
Hello.
Kai, you have to use this, man. Okay?
Okay, but Mr. Shaman, welcome to our show.
Thank you very much.
I hope you could tell us all about this nice device. I've been using it a little here in our shack. I have to explain all to our attendees and our readers. Okay. But maybe you can tell us all about it.
Well, a couple of things that I've seen your introduction at the beginning when you started with, is it just voltage controlled power supplies and one channels and two channels? Well, this one is a 3-channel version. We have 1 and 2 channel versions as well of this power supply, and now we have 3-channel version, which is this one. And one of the difference to what you have explained before is that you have an overcurrent protection, for example, in this unit. Every proper power supply nowadays has an overcurrent protection. But the beauty of this one is you can combine the channels. So you have the opportunity to, like, for example, you have a PCB with 5 volts, 3.5 volts, and you have a fan that cools the whole thing down. And if you notice on one channel you have an overcurrent situation, you can switch off that channel. But if normally you can kind of like say from an R&D point of view, if you have a problem on one rail, on one current rail, you might also have a problem on the whole system. So it's better off to switch off the whole system. But instead of switching off the entire all 3 channels, you can just say, okay, I switch off the 5 volts, the 3.3 volts, but I leave the fan running to cool the whole thing down. And you can do all this with one instrument. So you're completely flexible in combining the fuses, the electronic fuses, for example.
That comes in very handy, because very useful, because sometimes you have parts of circuitry, and then you know that this one is working, so you can power it up, and you're a bit doubting about the middle one.
Exactly.
So then you can get
you can see
if
it trips, basically you can basically switch over.
You can put the doubtable one on the current cutoff, and just leave the other one with everything, every current.
You can combine it, you can mix it or not mix it, you can run them separately. You're completely flexible with using the electronic fuses in terms of how to combine. It's completely up to you how to do that.
That's nice.
So that's one of the great features of it. Another very advanced feature is also the logging mechanism. All you need is a USB stick, FAT32 formatted. You put it in there and you can do data logging of the currents that is being drawn by a device under test or by your PCB. You can basically monitor the current flow as a CSV file directly on a USB stick. And you can basically log as long as there is capacity on your USB stick, or 4 gigabytes until FAT32 says thank you, I have enough.
We talked about that previous, but I was wondering how should we use that. But then it occurred to me that sometimes we have a circuitry and it works, and you put it on, and after an hour or maybe half a day or whatever, days or minutes, then it just suddenly turns off or goes bad, and then this is an ideal situation. You can just leave it on the power supply. If you have it in your laboratory, leave it on the power supply, put the stick in, go home.
Yes.
Eat
and see what happened during the night, and the next morning you can analyze it.
Next morning, 8 o'clock, just
take it off,
down, see when did it went down, and how much did it.
You could see a peak or whatever, something wrong.
Yes. For example, imagine you have a load. You load a accumulator. Do a battery loading or something like that. That whole loading process you can monitor, and it's a process that will take time. So this allows you to monitor it overnight and analyze it the next day. Just literally take out the USB stick, import the file into Excel, and make a nice graph out of it if you want. Do it however you want. It's absolutely
we'll do it like this. We'll
convenient.
Just plug it in and then go for coffee.
Yes, exactly. You have a very nice coffee machine here.
So just for our attendees, this is sexy, I know, but to know is that the file provided is like CSV.
Yes, it's just standard CSV.
So you could import
Excel,
that.
OpenOffice, whatever you want. You don't need a special software. The aim behind that was really make it as easy usable and as flexibly usable as you want. So you can really use the data how you want, because every system, every analysis system really can handle CSV files. So we really didn't want to provide a special new analysis software, but we wanted to make it as flexible as possible for you guys.
I think we like this one, I must say. We have some.
There is a downside with this one.
Yeah, I noticed. This is the downside.
There is another big downside. This is a very energy efficient power supply. So if your shack, if you're the place where you do all your work lab bench is in a cold environment, and you're hoping to use your power supply to heat up your environment, this is definitely not going to work.
So not for cold winter nights.
Unfortunately, if you want to sort out your heating problems with a power supply,
buy a heater.
Yes, buy a heater. Unfortunately, you have to buy a heater in addition to this power supply, because this one will keep your house cool, because the energy efficiency is extremely high. The channel board efficiency is in the area of 90%. 90%.
That's nice. But that wouldn't solve my problem, because we used to have an old tube radio, and you just put it underneath the table,
turn it on,
put your feet on it, so you had round and you had music.
Yes.
You can't do it with this one.
No, that's true. We have thought about that as well, but then we've seen the energy prices going up, so we thought maybe let's try and make this green. But I think we managed that with that.
Yeah. Well, it's not green, it's grey, but I think it's nice. Also, what occurred to me that the display you have here, it's
perhaps you can show it like.
Show it. Show it like this, and see if people can look onto it.
Yeah.
I mean,
even with the amount of light coming in from the left and right.
There are 2 or 3 lights standing on it, which you can see here, above here, and then you see them reflecting, and then still the display is very readable. I think that our attendees can read the display at home, and if you have other manufacturers doing this, then it occurred to me we have a lot of scopes and we have a lot of power supplies, but you always have to sit almost right in front of it.
Yes, I mean,
if your colleague is looking next to you or over your shoulder or looking from the right or the back, and he can just read it and say, yeah, you stupid, you fucked up here.
Well, I mean, the thing is, Hammick traditionally has a lot of enthusiasts as customers. We have an incredible amount of ham radio people buying Hammick equipment for really lots of years, and so we always cater for those customers as well. But these instruments are also made for the industrial use, or the main purpose of it is actually industrial use, which means you need an industrial grade display, which means you need that energy efficiency, because if you stack two of those, you have 6 channels in one 19-inch rack. If you stuck a 19-inch rack full of those in an AT environment, you produce a lot of heat. Even with that, you need a fan, even though it's got this high efficiency.
Does that mean you can only stack them, but you can also sync them together? Or?
No, it is just a source. It is not a sink, it's just a source. But if you have an AT environment, you normally have the requirement for many channels, which you then remote control. So there's a lot of thought has gone into this one in terms of remote controllability. And it's LXI conform. Like it's part of the LXI core class is done with this one. It's compatible with that. You can use USB TMC, so you can integrate it into your National Instruments world just by switching it in and downloading the driver, and that's it.
Okay.
So it's.
I think one of the best things of this. There's nothing to do with electronics, at least it has. But I think I have an older power supply, and it weighs 22.5 kilo.
Yes.
So this weighs.
Yes. It's
to the S, right?
Maybe it weighs 3-4 kilo.
I think 3.5.
3.5 kilos
is about the
right,
size, the weight of it.
So that means if you're going to somewhere or have to remove it from your shack and take it with you, well, I really don't want to take this 24 kilo power supply with me, because it's.
Man, but inside probably that one probably has like huge transformers and huge, most probably. If it's an old one.
Yeah, it has, but this has a regulated power supply.
Yeah.
Yes.
So it's switching power supply.
Big is not always beautiful if you have to carry it. So.
Yeah, right. Yeah.
Please don't. So well, I think do we have any questions?
I think now that perhaps we leave them for the end. We do have questions. Okay.
If our attendees have questions on the internet, please.
I think it would be great, because there's already a question here related to cheap power supplies, so to say. I mean, what a guy, I mean, Ton, our man in Elektor in the labs is already replying some of them, but he says literally price says it all. What do you think? I mean, do you think it's what do you think about a really extremely cheap power supply? Is it really worth?
They are talking about 80 euro power supply.
Yeah.
At the end of the day, the question is, what do you want to do with it?
Yeah.
If you just want 5 volt constant current, constant voltage, and 12 volt constant voltage, well, you can even take an old PC power supply and just
an ATX,
and use that. It really depends on what you want to do. I mean, if you want to have a proper adjustable ranges, if you want to have several ranges, if you want to start them synchronized, like for example, you can start the channels in this one in a synchronized way if this is a requirement. Normally the 80 euro one is not going to get you anywhere. It might help you heat your shack. But if it's a power supply you're after, then at the end of the day, if you want certain functions in it, you will not get them for 80 euros.
Okay, man, we have lots of questions. Crazy. Can we address them all? Yeah, you feel like
we can have a look.
Yeah, go for it. Okay, is there a specific point to investigate to add current limitation and switch power supply? It's a question from Xavier Paquet. Xavier, I hope you are there.
I have to understand.
Actually,
I have to admit I don't quite understand.
Actually, Don is asking, do you mean?
Is it possible to combine 2 agencies?
Yeah, Stefan Dietrich.
This was
all right. So he wants more than just 3 channels. He wants 6 channels.
6 channels.
It's the same question I was asking.
6 voltages simultaneously.
No, you cannot. You can sync the channels of the 3. And get your. This is about the question is what do you mean with sync? If you want to sync them really in the microsecond, no, there is no possibility to track that. No, there is no direct functionality to track that. Unfortunately, not. Sorry.
So what happens if we take the two exits and we take one as a 0.
Yes.
We have one as a negative, and we have one as a positive.
Yes.
Okay, that's possible.
Yes. Because they are all galvanically isolated.
Okay, they're isolated. Okay. And I take the second one, but because I think this is what this gentleman means with the question. Takes the second one. And
you can like track the behavior of 6 voltages at the same time. I think that's what he means.
If he means that tracking in
Yeah, like recording via USB.
What's
happening?
The difficulty is that you have two files basically.
Yeah, right. Yeah.
And when we talk about synchronization, we talk about millisecond synchronization, which kind of requires a signal to come out from here and start the next one.
Yeah.
So that is not
There is not a direct way to do that. You can start the measurement, and you can switch on the channels remotely with an external trigger input. You can do that, but you would need an external trigger output of the power supply to then activate the next one. So you can try and do that with one of the channels, but that's possibly you can work around it. But I cannot tell you exactly in terms of microseconds about the synchronicity.
But if they're electrically isolated, then that means that we can have one power supply to the negative pole and one power supply.
Of course, if you mean that with synchronization, yes.
I think it means that.
The difficulty is when you talk to when we're talking about synchronization, then we mean synchronizing the channels in terms of logging.
No, good. You have to have to preset the channels of each power supply. And if you have that right, then it will be no problem to have one doing negative voltage and the other one on top of it doing the positive voltage.
That's not the problem, because every channel is galvanically insulated.
So I hope this answers the question of the.
Yeah, in this case, it was a question of Dietrich, Stefan Dietrich. Yeah, and now next one we have a question from Eric Derbil, and he's asking what? Yeah, I think I have to speak here. What power supply do you advise us when we would like to proceed ADC with a voltage reference?
So,
to proceed ADC, he means like to power
digital converters, but do you want to?
Yeah. It's actually.
So another one says depends on the application, which is a very good answer from.
It's done.
Yeah, go on. Don't be specific.
I think given the time, maybe.
This is actually, I mean, a smart question. Can the USB port be used as a 5-volt source?
That's a very easy answer, because normally USB requires 500 milliamps of power output, and you don't have that. You can drive a USB. You can drive a USB stick.
I know what you mean.
Yes, you can drive a USB stick.
Standard,
you cannot drive anything with 500 milliamps at that point.
Yeah. So no, man, don't do it.
No, it's a
good idea, though. You have to say, good idea.
This is smart. This is really.
This is engineering, you know.
Yeah, maybe design another one underneath. So you can load your smartphone while you're measuring something. Yeah.
Hey man,
we do drive our demo boards with the USB connector from the oscilloscope. We drive the demo boards with that. It's enough for that. We can do that.
Okay.
It can push 100 milliamps.
Yes, it can do that. But he asked for USB, and USB really technically is 100 milliamps.
So he's asking to use the USB power supply
to do more.
Exactly, like to load a gadget or something.
Exactly.
Not advised.
Not advised.
Nice. Okay, another question, and whoa, this is crazy.
We're getting a lot of questions from our attendees, so I hope we can answer them all. But I don't know if we cannot answer them all. And we were looking at them after this session. And we'll try to
address them in the lab side.
With the help of our experts in the lab and our experts here standing next to me.
I think we can reply perhaps a couple of questions
more. This one we can reply quite easily.
And then we move to the scope.
Yes. That's fine. That's fine.
Okay. Next question. I have to speak here. For example, you have a 5-volt switching power supply delivering 2 amps, and you want to never go over 1.5 amps. But due to the switching technology, it's going to generate some current edge at each switching point.
This one does not generate a current edge at each switching point.
This is the kind of behavior you get when you take an
80 euros.
80 euros or an 80x power supply with what you can do.
This one you set to 1.5 amps, and there is 1.5 amps. You don't have to worry about any kind of spikes or anything like that. Just don't worry about it.
Yeah.
This is made to make your life easy as engineering, because the idea is not that you should worry about this is your screwdriver. It's a working kit. It just has to function, and it has to do what you want. So that is possibly the reason why you won't get this one for 80 euros. You have to need a tiny bit more, but you don't have to worry about any kind of spikes. Set 1.5 amps and 1.5 amps.
So it's like properly filtered, obviously, and it's
it is a switching power supply, but it has a lot of linear filtering behind it.
Okay.
Yeah. Okay.
Okay.
Good one.
I think this will be it for now for the power supplies.
Yeah. Well, there's another. Okay. Yeah, man, it's crazy, but
Yes.
perhaps one more and then
The
scopes,
answer,
okay?
the answer there was
Yeah.
a totally different one. It was below. It was a bit below. It was the
Yeah.
next one.
Yeah.
That's the easy answer. Is it possible to add a network interface to an HMP4040?
Yeah.
Yes, it is. The option is called HO730.
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 We'll have to write down that thing, later. Sorry, for the reference numbers. We're not good with that
Yes,
one.
that's no problem. But you can do that. No problem.
Okay.
But we will be seeing those attendees.
Well, it's the same thing. If you have those questions, collect them and pass them on
Yeah.
to me. If they're Hamik specific or Rohde & Schwarz specific, then I can at least the Hamik ones I can definitely answer. The Rohde & Schwarz ones I can pass on if it's.
Yeah, but the very last one I can even reply that myself.
you just said that
Is there any fan noise
times.
hearable in idle mode? No, it's not, man. I mean, we got it here and I don't hear anything. And it's in idle mode right now.
It's an idle mode. It
idle
doesn't do
mode,
anything.
It's not supplying anything. I should hit on a master on off, right?
Yes.
And now it's supplying power.
Now it's applying power, but obviously you're not drawing any power.
Yeah, obviously I have
But,
0
uh,
milliamps.
You will hear the fan power up.
If
and
I'm
then power down.
drawing current from the power supply.
No, but if you just switch it off, if you just switch it on, it will power up, and after a couple of seconds, it will power down and actually even switch off. So you don't have to be worried. The fan still works, although it might be switched off.
Because I had my Indo over here and it was on, but it was not blowing. You don't hear it. At least I have one ear free and don't hear it.
It's a big fan, first of all,
Yeah.
spinning
So-
very slowly. That is
that's
one
good.
thing, and there is a very good temperature control, because that is another thing. We don't want to have this. We built these as well in mind to have them on our workbenches at work, and you don't want to have a noisy machine on your workbench. You just don't.
Yeah, I mean, for that you already have your colleagues, interrupting you all the time and making.
Exactly.
It's speaking in Spanish.
Well, on the other side, it might be handy if you have like a turbine noise audio on your desk. You just can't hear anything else, so it might be a filter. But really, the idea is to have instruments that are as quiet as possible.
Yeah.
Okay, I think now we have to move on.
Yeah, we move to the scopes now.
Yeah,
we move to the scopes, guys.
We
Yeah.
move to the scopes.
So scopes. We love scopes, and we are lost.
Just stay here. We'll be
Okay.
getting
Questions,
what's
obviously.
coming in. We'll be getting lots of questions, so it's booming. Okay. Keep your questions coming.
Yeah, guys, we'll try our best because this is crazy. I mean, it's pumping.
We're just going to talk a bit about oscilloscope. Of course, there's a lot of different oscilloscope, analog, digital, single input, multiple inputs, storage scope. Also, we got a question from a guy who wants to know about. He says just talk about spectrum analyzers. It's also a different kind of story. But we have also nice news on this one. We'll get back to it later. I think we talked about it already. So we'll put this on the floor because we don't have this much space.
Yeah.
And then we're going to talk about it. What kind of scopes do you need when you're starting? What kind of scopes don't you need? For instance, it's also so that with a scope you get what you pay for. So that means if you only have a budget of maybe 100 or 200 euros, today there's small digital scopes which you can just put on your laptop or this kind of stuff. We had them; they're nice, and especially nice if you have to take them with you. But
you need a computer then as well.
You'll need a laptop. You'll be needing a laptop. Yeah. Okay, I think we'll go to the next slide.
Yeah, we go. We gotta move fast. Go. Okay, question from Mr. De Laurel, sorry, my French is
And he says, I'm a newbie with oscilloscopes. Probes, are they universal or must you match those to your scope, and if so, on what basis?
I have a probe here.
Well, they should be matched. That's for one. They should also be calibrated.
Wait. You have my probe and the cable of my mic.
Hello?
So wait. You have everything with you.
We're just having a rush here, but I think,
Oh, it's wireless. It might be wireless.
Well, but the answer is no, basically. Are probes universal? No, they are not.
No, they're not.
Absolutely not. There are probes that normally come with an oscilloscope, which are the passive
I think
probes.
it's a legitimate question because
Absolutely.
if Mr. Delore is a newbie to oscilloscope, so when he buys one, he only buys one,
Yeah.
and they come with probes.
Yes.
But what happens in our lab is that we have different oscilloscopes, but we have also different probes hanging on.
For instance, I'm gonna bring more from other scope right now.
Yeah.
Yes.
And then we have different oscilloscopes. So we have also. Yeah.
Can it
doesn't
is,
need to run.
They have also different. So we just what we do is we just turn and we grab whatever is on the rack.
Alles klar.
And then we put it on and then start cursing because it's not working properly or we are seeing something on the scope that isn't matching right and all this kind of
I have
stuff.
another one here.
Well, if we concentrate on passive probes, basically, you don't need to tip on that, you
you
just
need
use
to-
it like that. If you concentrate on passive probes, they normally come with this BNC connector.
Yeah.
Okay.
Every probe has that.
Yeah, but you can see already the difference between the BNC connector of this one and of this one. You have a separate pin that comes out here, and this pin is the information about what kind of probe is that. It's about the, is it a 1 to 10, a 1 to 1, or a 1 to 100 probe?
The older ones,
I mean, is
the older
multiplier,
ones
yes.
have a switch on it.
Yeah, no, it's not necessarily the old ones. It's just this one has it as well.
yeah.
So the one that comes with the HMO 1002, it has a switch. You can just set it.
Yeah.
You have machines that simply have the possibility to then obviously talk to the probe. The more complex your machine goes, normally the more complex the probes go. Like this one is the one for the HMO 3000, like the one they have over there.
I can show that actually. So that probe we have here, guys, is
It's for this
corresponding
one?
to this unit, which is not a hobby unit.
Not quite.
No, I think I'm
channels,
gonna
it's
save
very
some
nice.
Four
money.
channels, 500 megahertz.
Yeah.
This is not necessarily the one you need on your workbench in your cellar.
Yeah.
Depends if you're
It's nice to
doing,
have, though.
doing high
Yeah, you don't also need a Ferrari, but you know.
It's nice to have.
Yeah,
But
exactly.
it's nice to
So,
drive.
yeah. So yeah, always the same story. But yeah, as we can see here,
This is definitely more affordable than a Ferrari.
yeah, obviously, yeah.
Just imagine the running costs.
At
And
least,
you don't have to fill it up with gas.
yeah, right. But at least this was the probe. Yeah, for instance,
Yes.
this is connecting exactly, and it has. Wait, man, I'm messing
That's easy.
things
No,
up.
you
Yeah.
do it from the other side. Yeah.
You're
Yeah?
struggling.
Oh,
right?
okay. Now, perfect. Yeah,
That's in there.
great.
Okay. And this scope would recognize at that moment it's a 10-to-1 probe. It would just recognize it. So if
Without the need to set the multiplier.
you can
manually,
set the
yeah.
multiplier manually because you decide you want to do something different. You can, as a user, always override the instrument. You can
Yeah.
tell the instrument what to do, but the instrument will make a recommendation and say, hey, I recognize this is a 10-to-1 probe, so you don't need to do anything. If you buy a scope which comes with
This one.
that comes with a probe like this, then and you decide to change from 1 to 1 to 1 to 10, then you have to make the adjustment in the instrument.
On
But
the
it's-
oscilloscope.
Yes, but it's not a problem. You hit menu, you say probe adjustment, and you just change it, and that's it. It's not a big deal. And really, the good thing is because your customer or your Mr. DeLaurel, he seems to be very worried about can he break something.
Yeah.
And no, I have another probe here actually. I have a tiny probe.
Good.
But I just
hold on to this one.
nicked from
Yeah,
my
sure,
colleagues
Put it
at
on.
the Rode and Schwarz booth. I just nicked that from my colleagues at the Rode and Schwarz booth. This is a 3 gigahertz active probe.
So we're doing this on the fly. So
Yeah. This is a 3 gigahertz active probe.
Wait.
Which has been
you take that.
Okay.
which has been taken from Rode and Schwarz. And I have to bring it back, otherwise I think they kill me. And you can already see the different connector. You can see that the
Yeah.
BNC
Can we zoom in because honestly I've never seen this before.
the connector. This one doesn't only have one pin. This has actually 6 pins, and it properly communicates with the scope even more. Like for example, you can turn on and off. You can even turn on and off the measurement at the tip of the probe. It is an active probe, but you can see already from the way it's made, it's not possible to accidentally switch it on. It will not go in, and it shouldn't go in because it's not a standard BNC. It is specially made. So the rule of thumb though is you can't really break it because there are mechanisms that protect you from making mistakes at that point. And also if you have a 3 gigahertz active probe,
Yeah.
you know what to do with it.
Right.
This is not hanging in your lab and you can accidentally switch it on.
No.
People who have
but
that
you will
take
see,
care
you
of
will
it.
notice the difference.
Yes.
Yeah.
Yes, of course. I mean that you, for instance, that you don't notice the difference for this one and the simple one.
Yeah.
That's okay,
Yeah.
but you cannot break it.
No. Nothing with it.
So you connect. I mean, you can actually connect this one. Just let me try it. Right.
Yes,
yeah,
of
you
course,
can. Yeah.
of course,
this
of
one.
course, of
And you can work with this one.
Yeah, you can.
actually.
But
also-
the only thing, of course, is if you have this is a probe that is like a 100 megahertz probe.
Yeah.
If you attach a 100 megahertz probe to a 500 megahertz scope,
You are misusing the probe with
Exactly.
a proper, better
the
scope.
measurement that you're getting is not going to be the one you want if you're measuring a signal that is somewhere in the 200, 300, 400 megahertz.
It's like a Ferrari with a deux chevaux engine in it.
Yes.
Yeah. Well, it probably is not the engine of the scope. I would say just the wheels, perhaps.
And also, what's very important, a lot of people they say, I have this square signal, and it's only 50 megahertz, so I can use a 50 megahertz scope and actually see something. No, you won't.
No,
you will
but-
just see the sine wave,
Yeah.
because
And the rest and the spikes and everything that's
Yes.
above you won't see.
yes, exactly,
Yeah,
because
that's,
you just have to see that there is the rectangle, the square one is an addition of sine waves of
Yeah.
certain.
It will look suspiciously beautiful.
Exactly.
Because you're not grabbing the rest of the information. Yeah.
Yes.
Obviously. Yeah. Huh. Okay. Can we move on? I think and take this body out of the desk
Yeah.
and put it in a safe place.
Yeah.
Yeah. Let me just. Okay. Yeah.
Okay.
Okay. Go.
We'll put this.
Yeah. No. Not below.
Not below. No. And this one also. Jaime always wants to drink coffee during your session.
Yeah.
so,
Sorry, man. Yeah. One day something terrible will happen. I will ruin your laptop.
Okay, we should go to the next.
Next one. Yeah.
question.
Go. Okay. Okay, we have another question from Mr. Wilmer. It says, he says, what major advantages does a mixed signal oscilloscope offer versus a classic DSO? Should I rather get two separate devices, a logic analyzer plus a DSO, or will an MSO replace both devices? Does the Orange Buffed HMO 1002 offer MSO capabilities?
Yes.
Yeah.
Yes. So first of all, the RS HMO 1002 has
We have the
HMO.
body here, so
Yes.
perhaps we can,
Great.
we can
Excellent.
put it, we should put it there.
You can see the connector for the MSO probe. You can see it here. Here is the connector for an 8-channel MSO probe, and the big advantage, of course, is if you have the requirement of more than 2 or 4 channels, then it always comes handy if you have a couple of digital channels as well. The downside with the digital channels is that the probe actually has a Schmidt trigger in it. So basically, you only get a signal 1 or 0. You only get the 0, 1 or 0. So if you actually want
It's
to
a
have
logic
yes,
signal.
exactly. If you want to have a look at the edges of a signal, then you need the analog inputs for that. But on the other side, if you know that your edges are correct and you just want to analyze and monitor the data,
Where is my data standing? Am I synced in right or this kind of
yes.
stuff?
Or for example, if you want to see the latency between an analog signal and a serial bus signal I2 square or SPI, then you can use the SPI and I2C. You can run on the logic channels while you check your other analog signal in parallel on the analog signal, on the analog input. And that actually answers the question. It replaces your analog scope and your logic analyzer, as long as you don't want to analyze megabytes of data. The moment you actually don't want to do logic analysis, but you more want to do data logging, then you kind of need a data logger. But there are data loggers around that you can link with this machine, because this has an external trigger out.
Yeah, we saw that, yeah.
It's on the other one. It's on the other one. It's on the back.
Yes,
On this
yeah.
one, it's on the front. You use the aux out. You can set it to have the trigger signal to go out, and you can just sync that with a data logging device, and then log hours of data if you want.
And what for us or for our laboratory comes in handy, I don't know if other people doing that, but sometimes we want to take pictures of scope images.
Screenshots, you mean?
Screenshots and all this kind of device, and it has, of course, USB entrance. So you can just put a stick in and press a button.
File print. That's it. And you've got a PNG of the screen on your stick. It automatically
We can
sets
publish
a
that
name.
in your magazine.
Yeah, sure.
Okay.
Sure. Of course.
or on our website.
You can just basically, you have the...
We would like to show the people that if we're measuring, they should be have the same measurement, or else there's something wrong with their circuitry.
Yeah, absolutely.
So it comes for us. It comes in very handy. So
the short question, the short reply is no. Don't get two separate devices. Just go for
Also,
one.
you need to spend a lot of time to sync them. So if you just want to, if you want to sync two devices, it is an awful lot of effort to do that. And the MSO world kind of like makes life easy. Again, these kind of instruments, they make your life easy because you can concentrate on your task and not need to worry. You don't need to worry about your setup.
But it can also do spectral analysis?
Yes, it can. It has a FFT function. So actually, your attendee before who said talk about spectrum analysis, you have that in this instrument as well because it has a 100 kilopoint FFT functionality, which actually is just one push of a button. If we would have a sine signal or any, it's just basically where is it from this side? It's FFT. Up here it is.
Transform.
Yes, exactly, because that's how the spectrum analysis in scopes normally gets done, is with a FFT.
Hey, now we have a zoom in, and that's great because we're gonna give it away like soon. So yeah, guys, stay tuned.
We're going to give it away?
Yeah, sorry.
I think I'm keeping it. I'm keeping it.
Sorry. That's not gonna happen. Okay, so yeah, can we move on? Yeah. Let's move for the next question.
Yeah.
Okay, yeah. Actually, now we already got your reply.
Now we can go to the questions.
Now we're gonna address some questions. We're gonna address some questions here. Okay, wait. I'm checking the questions. Wow, man, this is massive.
Currently, an analog scope. What is the interest to buy an analog scope? That's easy to answer. There are no analog scopes around
no longer in the market anymore.
You can't get the tubes anymore. Actually, in your country, in Holland, there was the last company in Europe that supplied those tubes. They're gone. You can get them.
It was Philips?
It was a daughter company from Philips. Yes. And in Japan, there was another one, which was Toshiba, and they were the last ones who supplied analog tubes. But they both stopped production of those tubes. And you can get some in China from very strange
also
suppliers.
Russia is really popular.
It is. The difficulty is if you want to produce a quality product where you want to be sure that they don't start to break after 2 weeks or something like that, then it's unriable to use them. So
This
is the one.
Well, this is actually a ray cathode.
Maybe could we have the oscilloscope also, the Elektor oscilloscope? Electroscope.
Yeah? Let me bring it.
Because then we can show this reader what it all came from. This is one of the tubes that were used in the electroscope, because in the old days you had to buy a tube, you had to do your own steering, you had to own.
Let's make some room for grandpa.
It takes a lot of room.
Yeah.
This is the grandpa of the
grandpa. Yeah.
And.
This is Opa.
This is grandpa.
Opa Ossi.
If you see what's in here, we made it. I think it was 25. No, it was more than 30 years ago.
Yeah.
And since we built it in our lab, and then it still works.
Okay. Of course it works,
but
man.
there's only one downside. Somebody in the lab cut plug.
It was the health and safety person in your company. It was the health and safety person who took it off.
No, he wanted us to get a new one.
Yeah, possibly.
But we'll be putting it on the website also, so you can compare these two.
Yeah, but we're not going to give this away.
No, we're not going to give that away.
Okay.
We only have one of them, so we're not going to give them away.
Does it have a pattern generator as well? 50 megabit pattern generator?
I think it has a 50 hertz.
50 hertz.
Yeah, it's called noise. You know, in this case, it's called noise.
Yeah, that's okay.
We have another look at the pictures. We'll be giving this one away. Actually, not this one, but one
HMO 1002, brand new, without fingerprints of the product manager.
No.
Yeah. Okay.
Have you noticed that I've been?
Yes.
Yeah, okay.
Move. We have questions from people, guys.
We have questions.
Focus. Okay.
Focus. Yeah.
What means the value after the probe attenuation? 10 divided by 1.
10 to 1.
Actually, 10 to 1 or 100 to 1, and why it has frequency?
Well, the probe attenuation, obviously, for example, if you have 230 volts in your home socket coming out of your power socket, 230 volts is an effective voltage, so the peak power would be 325 volts. If you plug in that into your normal scope,
In a
one-to-one, the maximum input is 100 volts peak. So you would basically kill this within seconds.
A blink of an eye.
A blink of an eye, it would be dead.
And this is full of magic smoke.
Yes.
So there's a lot of magic smoke
exactly.
to release.
Yeah, it might make you feel very dizzy for a moment, but I don't know. But
Then you can use it as a heater for only once.
yes, once. It makes it very hot, possibly. But no, it will be basically a sudden death, as they say in ice hockey.
I think your wife will be very hot and smoking if you burn it, because
She'll buy a lot of shoes. So, but basically the thing is that if you still want to measure your AC output voltage of your power socket, all you need to do is you need a probe with an attenuator of 10 to 1,
10 to 1,
because
you can
your
measure
325 volts become 32.5, and 32.5 volts is something that a scope can handle.
Can handle,
Yes.
yeah.
And if that's not enough, then you can use 100 to 1 attenuation, which basically
you
would
can do
mean,
kilovolts.
yes, you can do kilovolts or take your 325 volts and make a 3.25 volt out of it. So basically it's just the divider.
Yeah.
It's an attenuation, so it's a divider that just helps you to
To increase the range,
Yes.
natural range, using a trick, so to
yes,
say.
exactly.
Yeah.
It is effectively a trick, yes. And the better the probe, obviously the more natural and
Conversion.
better quality is the conversion.
Yeah.
It's, again, it's like you said before, you get what you pay for.
You get
right?
what you pay for.
But you always
Okay.
But you always have to think what you need it for, and why does it have a frequency? That's easy because it's designed to match a certain bandwidth,
Yeah.
and the frequency is the bandwidth. So, for example, these probes, they have 100 megahertz as a maximum bandwidth. Use it with a 100 megahertz scope that it comes with, and everything is fine.
It's all right, yeah.
But just don't be surprised if you use it on a 500 megahertz scope and a 100 megahertz scope. You will see a much lower signal. So basically,
It will do some trick, but not
it's
trick
not
one.
what you want to see. So basically, the probe has to match the oscilloscope.
Scope. Yeah.
So guys, don't do like us. Just grab behind you anything you get. Just match it.
Yeah. Oh,
Read.
now
Yes,
we
read.
really need to speed up because
Yeah,
we
we
have
really need to speed
4
up.
minutes.
I want to explain to our attendees. I see there's a lot of more questions around scope and also around power supply. We will be answering them. I think we will be up all night.
Yeah?
Now we only have 3 minutes.
Yeah.
Our expert will help us with answering questions.
Yeah, we'll go to our booth. We have a party tonight at our booth, so you're welcome to join us there. Bring the questions, and we all
All
sit together.
attendees, join us
Yeah, I mean, because I mean,
Rodenstrasse, 307.
no, but some of them are really good. I mean, it's really good stuff. You know.
But we only pick one question, and then we go on to the scope giveaway.
Yeah, but I mean, yeah. Just last question. Will there be USB trigger in future?
What is a USB trigger?
USB trigger, I guess. I mean, it's like someone wants to kickstart another unit to work or something using the USB.
You can
Something
build
like
something.
that.
You can build something with an external trigger. You can
Yeah.
build something with an external trigger. Use the signal, but you need to do some kind of electronics to actually get that kickstart functionality if you want it.
I also
okay.
wonder what he's exactly meaning. So
It's kind of weird.
Yeah, please, if you know that you're attending, so
Stefan, if you're watching us,
please
I know
explain
you are.
to
So
us so we can write proper
get back to you.
questions.
go. And now we really have to give this body out. So
Oh yes, you have 2 minutes.
give
so-
away. Yeah,
Have
go.
2 minutes.
How are we doing this, guys?
The next,
need-
Next slide, sorry. Yeah. Questions, we already
Questions.
addressed a lot.
we have to do the giveaway, or else no one will be happy. This
So yeah,
afternoon.
giveaway. Go. How?
Okay.
Fast.
Can we
Have you
get
thought of that?
Can we get a list of
Yeah, the list
our
of attendees. Can
Yeah.
we get it? Is here. Where's the list of attendees?
Here it is it?
Yeah, here it is. Is this actually?
Okay.
Oh, you.
We'll do it.
here. Yeah.
We'll do it.
Yeah, I got it. Okay, guys, fast. We have 1 minute. Yeah.
Okay.
minute.
So I would like to thank you for your input, but I would
you very
like to
much.
to give you one more honor. I would like to lend your
Choose.
finger.
Okay.
Lend your finger.
Okay,
And just
fine.
lend your finger on here.
No, here, on the middle of the
Here.
screen. Yeah.
Jaime, start scrolling.
Okay.
And
And I say
scrolling.
stop.
And you stop.
Just say stop.
Okay. Stop.
Okay.
This will be Michael.
Michael Krämer.
Michael
Michael
Krämer.
Krämer. Congratulations, Michael Krämer. On a scope like this.
Yeah, you just won. You're an attendee. You just won this HMO 1002
MSO.
MSO.
So yeah.
So,
Michael, we'll be in touch with you soon. And
you'll get a brand new one because this one I put my fingerprints on it. You won't get that. But for now, I want to thank all of our attendees. I want to thank.
Yes, thank you very much. Thanks for having us. And tell us questions if you want to have any input from us.
We'll be in touch.
Yes, absolutely. That's fine.
And for now, if Jaime goes to the next screen.
Hope to see you.
Hope to meet you next time. And thank you for your input. Bye bye, guys.
Thank you. Bye bye. Bye.